This video is 3.7. I can graph systems of linear equations. And a system of linear equations just means two or more linear equations. And remember, linear means they're a straight line when we graph them. And this got cut off a little bit to be systems and solution. The solution to a system of linear equations is where the two lines intersect. So the answer for these is going to be an ordered pair. Sorry, let me zoom out. Where the lines intersect. So this box is supposed to say numbers of solutions of systems of linear equations, and it says two lines with different slopes. So if they have different slopes, the lines intersect, and there is one solution. Oops, sorry, you can't see that. I fixed the stuff that didn't show up, and then I said if they have different slopes, the lines will intersect, and there is one solution. If they have the same slope but different y-intercepts, so these lines have the same slope but they cross the y-axis at different places, the lines are parallel, so they never intersect, so there are no solutions. There are zero solutions. This one is actually two lines. It looks like one, but it's two lines right on top of each other. They have the same slope, they have the same y-intercept. The lines are, we're going to put the same. So there are infinitely many solutions. Sorry, that looks like one word. It should be infinitely many solutions. So for these first two, we're going to find the solution to the system of linear equations. The solution is just where the two lines intersect. So I know the graph is kind of hard to read. So look at this point right here. And we're going to figure out where the two lines cross, and that's going to be our answer. So if you look closely, and like I said, I know it's hard to read, we're going to look for our x-coordinate and our y-coordinate where the lines cross. The x-coordinate is 1, 2, 3, 4. The y-coordinate is 1, 2, 3. So the solution to that system is 4, 3. This next one, again, the answer is where they cross. The solution, it's hard to read. The x-coordinate is 1. The y-coordinate is down 1, 2, 3. So 1, negative 3 is where those two lines cross. Okay, most of the time you're going to have to graph the equations yourself. You're not going to be usually given the graphs. You're going to have to graph them yourself and then see where they cross. So if you look at example 1a, it gives you two equations, and they're kind of hard to read, so I'm going to rewrite them. The first one says y equals x plus 2, and the second one says y equals 2x plus 1. So we're going to graph those equations, and we're going to see where they cross. Where they cross is going to be our solution. So for this first one, we're going to start with the y-intercept. The y-intercept is 2. And then there's an invisible 1 in front of the x. To write 1 as a fraction, I say 1 over 1. So from this out, I'm going to go up 1 to the right 1, up 1 to the right 1, and I can go back the other way. So there's my line. Then for this purplish one, I'm going to graph the y-intercept is positive 1. And the slope is 2. 2 as a fraction is 2 over 1. So I'm going to go up 2 to the right 1, up 2 to the right 1. I can keep going this way to make it more accurate. And remember, the solution is where they cross. So the solution to this problem is 1, 3. The answer is 1, 3 because the lines cross when x is 1, y is 3. Okay, same thing with the next one. So for the next one, we're going to graph those two equations, see where they cross. So, sorry, it's having trouble reading that. It should be y equals negative 1/2 x minus 1, and the other one is y equals x minus 4. So to graph them, for the blue one, the y-intercept is negative 1. The slope is negative 1/2, so I go down 1 to the right 2, down 1 to the right 2. And then there's my line. For the purplish one, my y-intercept is negative 4. 1, 2, 3, 4. My slope is positive 1 because there's an invisible 1 there. 1 as a fraction is 1 over 1. I'm going to go up one to the right one, up one to the right one. So they cross right here at 2, -2. So my solution is 2, -2. Okay, for my next one, we're on the next page. This one is, these are close to slope-intercept form. They're just written backwards. I'm going to copy them the other way just so it's a little bit easier for me to graph. So I'm just going to rewrite y equals 2x minus 6. I didn't change anything. I just reversed what was on each side of the equal sign. And then y equals 3 minus x. So for the blue one, the y-intercept is -6. So I'm going to have to go down one more below my graph because the graph only goes down to -5. And then the slope, let me zoom out, the slope is +2. 2 as a fraction is 2 over 1, so I'm going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. I have to be careful on this purplish one because my y-intercept is 3. The y-intercept is always the constant term without the x, so it has to be the 3. The slope is -1. So I'm going to go down one to the right one, down one to the right one, until my lines cross. So the solution to this system is 3, 0. Because when the lines cross, x is 3, y is 0. Okay, then I'm going to go on to this one. This one is already in slope-intercept form, so I'm ready to graph it. The y-intercept is -3. The slope is 2 over 1, so I'm going to go up 2 to the right 1. So there's that line. The other one is not in slope-intercept form. It's close, but I need to get the y by itself. So I'm going to subtract 2x from each side. So I get y equals -2x plus 5. That means my y-intercept is 5. And my slope is -2. -2 as a fraction is -2 over 1. So I'm going to go down 2 to the right 1, down 2 to the right 1. So my solution to this system is 2, 1. My x value is 2, my y value is 1. This is what I want you to type in for your submission this time. Okay, this one I kind of wrote all over it. It says y equals 3 and x equals -4. That's not quite in slope-intercept form. It doesn't have an x in it. It just says y equals 3. That means y always equals 3. So if x is 0, y is 3. If x is 1, y is 3. If x is 2, y is 3. If x is 3, y is 3. So it's going to be a horizontal line where y always equals 3. This bottom one, x equals -4, means x always equals -4. So if y is 0, x is -4. If y is 1, x is -4. If y is 2, x is -4. So it's going to be a vertical line at x equals -4. So these two cross when x is -4, y is +3. Okay, this one, I'm going to start with the bottom one because this one's already in slope-intercept form. So I'm ready to graph it. I'm going to cross the y-axis at 3, and then from that dot it's going to go down 3 over 4. So there's my line. The top one is not in slope-intercept form, so I have to put it in slope-intercept form before I can graph it. I don't have a lot of space, so I'm going to write down my work on this other paper. So we have 3x plus 4y equals 12. I need to get the y by itself. So I'm going to start by subtracting 3x from each side. So I have 4y equals 12 minus 3x. Those aren't like terms, so I can't combine them. Then I'm going to divide by 4 on both sides to get the y by itself. So I have y equals 12 divided by 4 is 3, and I'll leave this part as a fraction, so minus 3/4 x. So if that's my new equation in slope-intercept form, what was it? Y equals 3 minus 3/4 x. I can tell that my y-intercept is the constant term 3. My slope is -3/4, so I'm going to go down 3 over 4. And then they're the same line with the same slope, same y-intercept. Remember, our solution is points that are both of the lines share, where they intersect. These lines share infinitely many points because they're actually the same line. So for this one, I'm going to write infinitely many solutions. There are infinity solutions because those are the same line, so they share infinitely many points. Okay, we have two more. This one, this top equation, the y-intercept is 2, the slope is 3, so up 3 to the right 1. I can go backwards if I need to draw more dots. The bottom equation, the y-intercept is -2, The slope is 3, so I'm going to go up 3 to the right 1. Oops, down there. These are parallel. They're never going to cross, so there is no solution. There are no points that are on both of these lines. And I can tell that's going to happen because they have different y-intercepts, but they have the same slope. Where if I go back to that last example, they have the same y-intercept, positive 3, and the same slope, negative 3/4. So no solution is same slope but different y-intercepts. Okay, last one, the equations didn't print. It's going to be y equals negative 3/2 x plus 5 and y equals x. So for this first one, the y-intercept is 5, the slope is negative 3/2. So I'm going to go down 3/2, down 3 to the right 2. For the second equation, the y-intercept doesn't have one, so I know I can add a plus 0, and that won't change the value of my equation, so it crosses the y-axis at 0. And there's an invisible 1 in front. 1 as a fraction is 1/1. So I go up 1 to the right 1. So the solution to this system is 2, 2, because that is the point that is shared on both lines.